ठीक, चलो. Good afternoon, students. I am Dr. Suresh Agarwal from the Department of Physiology, and we have been discussing hematology in the last few months. Today we are going to discuss about WBC, that is the leukocytes. Leukocytes means, leukos means white and cyte is cell. That means white blood cell. In fact, it is a misnomer. When you see the WBC, it is not white in color, in fact it is colorless. So, if we know something about how WBC is formed, where it is formed, what are the different factors which regulate the leukopoiesis, how it is released into the circulation, what are the characteristics, features we can see, and what is ultimately the function and what is ultimately the fate of the WBC. So, before we go into anything, here, again, we see the schematic representation of the formation of multiple different peripheral blood cells. Again, we see here, it is the pluripotent hematopoietic stem cell. This pluripotent hematopoietic stem cell, which is present in the bone marrow, is derived from its precursor, and that is the totipotent cells. Now, these totipotent cells gives you this hematopoietic stem cell, and this hematopoietic stem cell is committed for the formation of all the different series of cells which we find in the blood. So, if we see, it gives you CFU blast, which goes ultimately into the formation of RBC. Then we have CFU spleen, that is coliforming unit spleen. Then we have the lymphoid series, which gives us the T lymphocyte and the B lymphocyte. And ultimately, last but not the least, it is pluripotent hematopoietic stem cell last. This replenishes itself. That means the stock in the bone marrow should not be exhausted. That is why this pluripotent hematopoietic stem cell, it is replenishing itself. So coming to the WBC, here we see it is coliforming unit spleen. Now this gives us another committed units of cells which is known as coliforming unit GM. GM stands for granulocyte, monocyte, and coliforming unit M, and this M stands for megakaryocyte. So this coliforming unit GM gives us granulocyte and monocyte, and coliforming unit megakaryocyte gives us the platelet. So all this is going on into the bone marrow, the red bone marrow. Okay? Now the next slide. Okay. So if we see the classification of WBC, what is the basis of classification of WBC? The basis of classification of WBC is the presence of granules. Is the presence of granules in the cytoplasm, and accordingly we divide it into the granulocytes. That means the cytoplasm of the cell contains granules. These granules might be of any types, but they are containing granules, and the other is agranulocyte. That means there is no granules in the cytoplasm of the WBC. So there are three types of granulocyte which we can see: the neutrophil, the eosinophil, the basophil. And there are two types of agranulocyte: the lymphocyte and the monocyte. So today we will be more concerned about this neutrophil, that is the granulocytic neutrophil. If we see, where is the genesis? Where are these WBC formed? As I pointed out earlier, they are formed in the red bone marrow. So the first cell which is identifiable morphologically for the formation of WBC, it is the myeloblast. This myeloblast is a very large cell. It is a very large cell with a very large nucleus containing 1 to 5 nucleoli. But there is one very important thing which I should mention, and that is this myeloblast, it doesn't contain any granules. As the sequence of events will go, if you remember in erythropoiesis, the erythroblast did not have any hemoglobin. But gradually, as it developed, hemoglobin was acquired. Similarly here, the myeloblast gives you the promyelocyte. The promyelocyte gives you the myelocyte. The myelocyte gives you the metamyelocyte. And it gives again the band metamyelocyte. And finally, the different cells. That is, it may be neutrophils, it may be eosinophils, or it may be basophils. And gradually, what happens? As in erythropoiesis, there was a decrease in the size of these cells. Here also, this myeloblast, which is around 18 micron, 18 to 20 micron meter in diameter, this gradually decreases in size, and as the progression goes, gradually granules are acquired. You all have seen in your practical classes. I'm not going to go into the details of different WBC and all that, but just for recap, the WBC, especially the neutrophil. This neutrophil is around about 10 to 14 micrometer in size, and it has got a nucleus, which can be anything. It can be 2 lobes to up till 6 lobes. And as the number of lobes increase, it shows that the neutrophils is more mature. When initially the neutrophil is released into the circulation, usually it contains 2 lobes. But gradually as the time progresses, these lobes become 2 to 6, and this is what we do in the Arnett-Cook count. So the most important thing other than these lobes, we have time and again pointed out in the class that 2 lobes. The eosinophil also have 2 lobes, the basophil also have 2 lobes. So what is the main differentiating feature? The main differentiating feature is the presence of the granulocytes. And these granulocytes, what type of stain they take up? These neutrophils, they take up both the acidic and the basic dyes. As we have seen in the Leishman stain, may it be eosin or hematoxylate. It takes up both these stains. So the neutrophil, it contains fine granules. Fine granules. And these granules, they take both the acidic and the basic dye, that is the eosin or the hematoxylate. Now, of utmost importance, these granules are not there for the orientation or for the, जिसको कहते हैं कि श्रृंगार के लिए नहीं. Time and again, whenever asked what are the functions of these granules, what is the composition of these granules, you all fall wrong. But do remember, these granules, they are composed of many things which will ultimately help the neutrophil in performing its function. If these granules are not present in the neutrophil, neutrophil will not be able to perform its function. So what does this neutrophil contains? These neutrophil granule contains, they are fine, they might be violet or not violet exactly, purple in color under the microscope, which all of you have seen. But the composition of these granules, they contain many enzymes, many proteins, certain amount of lipids, certain amount of nucleic acids. The most important of them, the different enzymes which are present, they are composed of that. These granules, they are composed of those enzymes which I am telling you. They are like, they might be proteinases, they might be sulfatases, they might be metalloproteinoses, so on and so forth. And at the same time, they also contain certain amount of antibody which are known as defensins. And these defensins are active against the mice, active against the fungi and the bacteria. So I repeat, the granules are of utmost importance. These granules allow the neutrophil in performing its function, and these granules are composed of different enzymes, certain amount of lipids, certain amount of nucleic acid. And these enzymes, again to repeat myself, These might be containing proteinases, metalloproteinases, sulfatases, and so on and so forth. Okay? So, now going back to the one thing, and that is, we talk of total leukocytic count, that is TLC or total WBC count. Only one data is acceptable. Only one data. Total WBC count in a healthy human adult is 4,000 to 11,000 per cubic milliliter of blood. No other data is acceptable. 4,000 to 11,000 per cubic milliliter of blood. We talk of differential leukocyte count, that is DC. That means what are the different percentage of cells which are present amongst the granulocyte and the agranulocyte. As you see, neutrophils. Why they are called neutrophils? Because the granules take up, they are neutralizing, they are taking the acidic and the basic stain. Eosinophil. Why eosinophil? Eosinophil, the granules are taking the acidic dye. Basophil, again, the basophil, basic dye. So, we were on to the differential count. This differential count, if you see, the neutrophil are the most populous of the cells which can be seen. They fall to around about 60 to 70%. Then followed by lymphocytes, which is 20 to 40%. Followed by monocytes, 2 to 8%. Followed by eosinophil, 1 to 6%. Followed by basophil, which is 0 to 1%. These are the averages which we get. So now, coming to the characteristics of the neutrophils. What are the different characteristics? These characteristics help the neutrophils in performing its function. Number 1, diapedesis. Number 2, amoeboid movement. Number 3, chemotaxis. This diapedesis, what happens? The cells are being formed in the bone marrow. That is an extravascular thing. Now, these cells have to gain access to the systemic circulation. And what is the modus operandi? The modus operandi is by this method of diapedesis, these WBC, they gain access into the peripheral circulation. And you will be astonished to know, I was around 3 billion WBC cells, they gain access to the systemic circulation per hour. 3 billion. So, by this method of diapedesis, it gains access into the systemic circulation. Second characteristic is the amoeboid movement. Neutrophil is a motile cell. It has got its mobility similar to that of the amoeba. That is why it is known as amoeboid movement. Third is chemotaxis. If you split the word chemotaxis, chemo means chemical, taxis means movement. Movement which has been induced by chemicals. And what does this do? This chemotaxis, where does the chemicals come in from? Where does the chemicals come in from? The chemical comes in from the bacterial or the viral toxin. The degenerative products of inflamed tissue. If a tissue is inflamed, degeneration is going on. And these degenerative tissue are liberating certain chemicals, which are chemoattractants. Third is reaction products of the complement complex. And fourth is reaction products caused by plasma clotting in the inflamed areas. All these four, they induce chemotaxis. That means under the influence of all these chemicals, the neutrophil tends to move towards these, where the genesis is there, where it is being formed. So, under the influence of this, where there is movement of neutrophils towards these things, there is an aggregation of neutrophils which takes place. That means large number of neutrophils can be accumulated or comes together where these chemicals are being produced. One more thing. This chemotaxis is valid only up to 100 micrometers. But if you see, no cell of the body is away from any capillary. The minimum maximum distance which you can find is 50. And this is effective up till 100. So this is a highly developed method by which the neutrophils are dragged towards the site of infection where inflammation is taking place, where the function of neutrophil has to take place. Next slide. What is the functions of neutrophils? Simple one line, one action, and that is phagocytosis. Now, the question arises, why does not neutrophil phagocytize all the body cells or any cells which it comes by? There is a system, there is a method by which this neutrophil recognizes which cell to phagocytize and which not. So generally the cells of the body, they have a very smooth surface. And when anything goes wrong, any type of inflammation, any type of infection goes on, these cells which are very smooth, they become rough. Secondly, that smoothness was a protective method against phagocytosis. Secondly, the cells, they have a protective layer of protein. They have a protective layer of protein. When any infection takes place, inflammation takes place, this protective layer of protein is lost. Hence, those tissues, those cells become prone for phagocytosis. And third is, you make the cells more tasty for the neutrophils by bringing about a process which is known as opsonization. Now, we'll go into opsonization. What is opsonization? Supposing there is a bacteria. This bacteria, by the immune system, develops an antibody. So this antibody will come and attach itself to the bacterial membrane. Okay? Because the antibody which has been generated against the bacteria, this antigen antibody, this antibody will come and attach to the bacteria. And at the same time, this antibody, it has got a complement system. It will attach with this C3 component of the complement system. And this C3 component of the complement system, it has got receptors on the neutrophils. And it will attach to those receptors on the neutrophils. And hence making those cells more prone for phagocytosis. And this process is known as opsonization. Now, what controls the leukopoiesis? And what is the lifespan of a WBC? The lifespan of a WBC is variable. It has got 4 to 8 hours of lifespan in the circulation, and from the circulation it goes into the tissues where it can have a lifespan of 4 to 8 days. But this is variable in the sense, if the body is under the influence of an infection, these neutrophils are called to perform their duty of phagocytosis at the site of infection. And while performing their duty, they also die out. So there has to be a very rapid turnover, and in that case, the life of the neutrophils becomes very small. Usually, in the non-infected condition, where they are not called upon to perform this duty, the life is 4 to 8 hours during the circulation, and 4 to 8, around about 8 days in the tissues. And again, in the development of the WBC, which we have previously pointed out, the myeloblast, promyelocyte, myelocyte, metamyelocyte, band metamyelocyte, and the neutrophil. If you see, you can divide that into two. You can divide that thing into two compartments. One is the mitotic compartment and the other is the post-mitotic compartment. As you will understand, as you will see, as the terminology is self-explanatory, mitotic compartment means mitosis is going on. And that takes around 3 days. And in the post-mitotic compartment, it takes about 7 days. So, in a total of 10 days, this whole process, from the myeloblast to the mature neutrophil or the eosinophil, it takes around 10 days of time. But when the need is there, when the crisis is there, when the emergency is there, this period can be shortened. The post-mitotic period can be shortened up to 2 days. So, more and more neutrophils are available for the body to be defended by infections which it approaches. Now, there are certain things which will control the production of these neutrophils, and they are namely, number one, certain interleukins, especially interleukin 5, interleukin 6, interleukin 3, and the source of all these interleukins, they are generally from the T cells or the macrophages, and they have got effect on the bone marrow, which will ultimately result into leukophysis. So if we summarize, the neutrophils 10 to 14 micron in diameter, nucleus 2 to 6, fine granules which are neutral in nature, that means it takes both the acidic and the basic dyes, and the nucleus and the granules, they are composed of the enzymes which I told you, they are composed of certain proteins, they are composed of certain lipids and certain amount of nucleic acid. To repeat again, they contain proteinases, metalloproteinases, sulfatases, and so on and so forth. The maturation time, one more thing which I would like to collect is, these WBC which we find in the peripheral blood, they are merely a mode of transport. The blood is being used as a transport system. From the blood it will gain access into the tissues. And here in the peripheral circulation, the neutrophils, they are present in 2 states. One which is flowing, the other which are marginalized. Marginalized means they are attached to the endothelial surfaces. And especially to those endothelial surfaces which are post-capillary venules. And you'll be surprised, there are equal numbers of cells which are in circulation and those which are marginalized or in attachment to the endothelium. So if and when the need arises, the first response is these marginalized cells are released into the circulation and you get a rise in the WBC count. Immediate rise. So, summarizing that, neutrophils, and please do remember, granules are not ornamental. They have got their function, and by the granules only, the neutrophils are able to perform its function. Thank you. Sir. Okay, thank you, sir.